Hello everyone, I'm Weijie Guan, a second-year PhD student from Virginia Tech. Today, I'm excited to introduce our work EVINET, a framework that tackles open-world graph learning by reasoning about uncertainty. Our goal is to better detect misclassifications in novel classes in noisy, real-world environments where the closed-world assumption doesn't hold. Let me walk you through the motivation and how our approach works. Graph learning has been crucial to many real-world applications, but most existing models rely on a closed-world assumption, where all possible labels are known during training. In reality, this assumption is often violated because the environment is both open and noisy. An open environment means the model can encounter new or novel classes that do not appear during training. Meanwhile, noisy data or ambiguous information can mislead the model and cause misclassification. A typical example is financial fraud detection. There are many undiscovered types of fraud, and even known fraudulent activities can incorporate legitimate transactions to mimic normal users and make detection more challenging. However, most existing methods only tackle one side of this problem. This limitation leaves graph learning models vulnerable in real-world settings. To address this limitation, we propose EVINET, an evidential reasoning network that leverages uncertainty reasoning for out-of-distribution detection and misclassification detection. First, we use beta embedding to represent both nodes and classes with evidential uncertainty, which enables subjective logic operations such as disjunction and negation. Second, we perform dissonance reasoning to detect misclassification by quantifying conflicting evidence. This helps the model know when its prediction for known classes may be unreliable. Third, we apply vacuity reasoning to detect out-of-distribution samples. This measures the lack of evidence when a node does not belong to any known class. Finally, we integrate local and class-level context through context-aware GNNs, which makes the uncertainty estimates more robust and reliable. Together, EVINET provides a unified framework to handle misclassification detection, in-distribution classification, and out-of-distribution detection under real-world conditions. Thank you for your listening. If you'd like to learn more, feel free to scan the QR codes here for my personal webpage and the code for this paper. I'd be glad to connect or discuss more.